everyone, and welcome to Unit 7, Part 2. We're going to learn the rest of the stuff in our plate tectonics unit, and we're actually going to introduce the term plate tectonics today, because we actually haven't done that yet. But for today, we're going to talk about seafloor spreading and plate boundaries. I'm not going to read everything on the slides in this video. Definitely feel free to pause and read all of them. I'm just going to do more of a gist as we go through. So, seafloor spreading, we talked about that a little bit with the reading we did before we went on break. And basically that is where new crust is being formed. Molten magma is coming up through these plate boundaries right here, and they are forming new crust once it cools, once it hits the seawater. And as the plates get farther and farther apart, they just keep making new, and so basically it's like a conveyor belt of new crust. And so that is seafloor spreading. And then our mid-ocean ridge, which we've also talked about before, that is where the seafloor is coming up. And because it's forming that new stuff, it's kind of almost like a scab in the middle of the ocean. So it has this kind of raised bump right here, which actually, if we were down there, would look almost like a mountain. So we have this raised ridge right here. So it's a mountain range under the ocean. The reason we know about this is because of a lot of scientists, but specifically this guy named Harry Hess. So Harry Hess was a naval geologist, and he has sonar in the ships that he was on, and basically he was able to use the sonar to see underground and realize, hey, why is there a mountain range in the middle of the ocean? This is super weird. I thought the ocean was just completely flat, all sand all the time. And basically, if you have ever been fishing, or if you have on your fishing boat maybe a sonar where you can see basically the lake bed and see where you're getting towards, basically had that same thing, but he was able to see to the bottom of the ocean. And what he saw was something like this. We have this mid-ocean ridge right here, and we have some more over here. But basically, this is where seafloor spreading is happening. That is where the new crust is being created. And so he figured out that seafloor spreading should be happening based on some evidence. One, the mid-ocean ridge that he found. Two, the age of the seafloor rocks. We were able to figure out that here at the mid-ocean ridge, there was newer rocks than way over here. So we figured out if new stuff being created, old stuff is being pushed away, so the rocks are moving. Also, deep ocean trenches. So he figured out that not only is a new crust being created at the mid-ocean ridge, that old crust is being destroyed over here in deep ocean trenches. Because if new crust was just being created and created and created, we would just be getting bigger as a planet, but that's not how that works. So the old crust gets destroyed here at the deep ocean trenches. And then also GPS. We can figure out, oh, if we put GPS right here, we can track how much it's moving all the time. So that was our evidence for seafloor spreading. And finally, if we take continental drift and seafloor spreading, put it together, we get plate tectonics, or the theory of plate tectonics. So basically, it's the theory that the crust is broken into plates, and that the plates are moving. And so at the plate boundaries, where the plates meet up, some things are happening. This is explaining a lot of the stuff that we have, like earthquakes and volcanoes and islands that are being formed. There are three different types of plate boundaries that we're going to talk about. One is a transform boundary. That is when two plates slide past each other horizontally. So a transform boundary. And then as they slide past each other, it's not a perfectly smooth surface. So they're basically getting stuck as they go. And sometimes they get stuck and they're building up enough energy that when that kind of tension releases, that is when earthquakes happen. For example, the San Andreas Fault, that is a transform boundary. You can see there's an actual line there that you can see at some places, and so it transforms. Another one we have is the divergent boundary. So that is when two plates are moving away from each other, like at a mid-ocean ridge with seafloor spreading. They're moving away and the magma is coming up underneath. We have over here a mid-ocean ridge. So again, magma is coming up, new crust is being formed, and it's being taken away. Then we also have what are called rift valleys. So mid-ocean ridges are between two oceanic crusts, so crusts that are in the ocean. And then rift valleys can happen when there's two continental crusts. So when continental crust is being pulled apart. And so we see an example here. They're being pulled apart. All of a sudden we have rivers and lakes and possibly oceans being formed, and gets even farther apart here. An example of a rift valley is in Africa, and this is the Great Rift Valley. And so basically this continental crust and this continental crust are diverging, coming apart, and eventually there might be an entirely new ocean right there as they go further and further apart. And then the one we're going to talk about the most is a convergent boundary. So these are when two plates are coming together. And this is when all of a sudden we might have mountains form, or we might have what we call subduction. When you have a continental crust and a continental crust come together, that's when you get mountains. You don't get any volcanoes, just mountains, but you can also get earthquakes, because obviously there's lots of collisions going on when they collide. So that is how we got the Himalayas. That's how we got a lot of mountain ranges, came from continental crusts converging together. We have a subduction zone. So when two plates come together, instead of going up, they can instead go down. So subduction, that is when below, they subduct beneath. So we see here an oceanic crust and an oceanic crust. Subducting, one goes below, and then an oceanic crust and a continental crust, one also is going below. When you have an oceanic and a continental crust coming together, that is when the oceanic crust gets subducted, which is good, because if it wasn't, then all of a sudden, maybe South America would be taken underneath the ocean, which would be bad in so many different ways. Luckily, the oceanic crust goes underneath because it is less dense. That also can form mountains because even though it's going under, there is still enough collision there to form things and go up, and can also form volcanoes. Volcanoes can also form mountains sometimes. So that is oceanic and continental. And then we have oceanic and oceanic. Oceanic coming together with oceanic, basically two crusts in the middle of the ocean. That also has subduction happening. So whichever plate just happens to be less dense will go under. And then that also can form volcanoes. And then that's what can form some lovely islands in the middle of the ocean. That doesn't form all the islands, like the Hawaiian Islands aren't formed through this. They're formed through hotspots. And then an example of this would be Marianas Trench. So, oceanic and oceanic, we have subduction, causes violent volcanoes, earthquakes, and deep ocean trenches. So that's where the crust through subduction gets eaten back up so you can form new crust at mid-ocean ridges. And then this is what your notes would have looked like if you had taken them. Feel free to screenshot this and use this if you would like. Let me know if you have any questions. Thanks so much. Have a great day.